As I said, this is a fairly short chapter, so let's wrap it up with a couple of more points. So we said that the Indian Ocean region on this side has influence of the extratropics, which are involved in triggering the so-called primary MJOs, which are newly generated in the Indian Ocean sector. It's not always clear why some become secondary or MJOs and depend on the previous MJO phase, and some become primary, but nonetheless this is the kind of schematic I took from this journal without going into detail. It just shows what we had talked about before, the subtropical jet that always gives us the tropical extratropical exchanges. So we had talked about the convection driving Rossby waves, dispersions, changing vorticity tendency. Remember, vortex stretching and absolute vorticity having to be maintained as you travel across latitudes. So planetary vorticity changes and relative vorticity has to change. So you have these doublet of vorticity tendencies, and you create suppressed convection here, but the extratropical influence is also invoked for creating genesis of MJOs in the Indian Ocean side, and those are mostly argued to be coming from the southern hemisphere because that's the open ocean part. On the northern side you have Africa, where the 20 to 60 day signature is not very strong, and then you have the mountains, Himalayas and so on. So maybe Southern Ocean extratropical pathway works easier, but I just wanted to make a point that there is strong evidence that a significant portion of the MJOs seem to be triggered from extratropical perturbations. Impact of climatological state. Here we talked about the cooling in the east being responsible for MJO convection dying off as it propagates across either directly or south into the SPCZ, and some signatures continue on. But this is a nice paper from Wenju Chai and colleagues about the pantropical modes. So I'm just using it as a schematic for making the point about background state changes. So if you look at the seasonality during El Nino year going into El Nino plus 1 year, we are not only changing the Indo-Pacific basic state, these are the SST anomalies and convergence divergence anomalies. So all the wave processes that we talked about in terms of stretching and so on, and the connections through the westerly duct and the tropical upper tropospheric trough are going to be affected by changes in the climatological state, whether it's just the Indian Ocean dipole or the Atlantic Nino or the Pacific Nino. It's probably not so great to think of them as separate. As I said, maybe they are all closely related to each other, which is part of this part of the argument of this paper as well. So you can see that those influences go off into extratropics and across the pantropics. So nonetheless, MJO is basically MJOs are propagating in these with the basic state changing at seasonal and interannual timescales. So those are also important to consider. As a summary, this is from a paper, Xianan Jiang's 50 years of MJO with lots of colleagues, which is summarizing each theory discussed in the paper. So there is the weak temperature moisture mode, Vichy moisture mode, BLQE model, the trio interaction of Bin Wang, which have different essences. And the point I want to make is that there are many papers which use observational and modeling evidences and agree with all these theories. That's the main point I would argue about. This is a skeleton, gravity waves, nonlinear solitary waves, large-scale convective vortex, and so on. So sometimes you can think of it as blind men describing an elephant as a trunk or a rope or a snake or whatever. So the processes are all kind of similar. Emphasis is different. So it's the surface heat exchange, moisture loading, waves, convection, and so on. So nonetheless, the emphasis or the essence tend to be very different. For example, in the weak temperature gradient moisture mode, moisture convection coupling is key. Moisture advection is important for propagation. Cloud radiative feedbacks cause growth and determine the horizontal scale. Okay, so that scale itself depends on which theory is being used. In the Vichy moisture mode, moisture convection coupling is also key as before, but Vichy determines the propagation, growth, and scale selection. So it's the convergence of the winds into the convection, enhancing the wind speeds on the front, weakening them on the back, so moving the warm temperatures ahead and moving the convection ahead. That determines the scale, and cloud radiative feedbacks provide additional growth. So I won't go through all of them, but you can understand that while MJOs have been studied for several decades, so much data is being gathered, so many models are built, either full complex models or simpler models. There are still multiple theories, which means the processes are not completely understood. Okay, you have to be aware of that. Just like in the case of El Nino, we talked about several theories. Even in the case of MJOs, we have multiple theories. So it's a short chapter. We will leave it there, and we will do the monsoon and talk about the specificities of the northward propagation of the interseasonal oscillations during the boreal summer. Some people refer to them as MJOs as well, and some people call them BSISO, Boreal Summer Intraseasonal Oscillation, and they have some specific characteristics of their own, and they're just going from the equatorial region into the Indian subcontinent, and we will see that in the next chapter. Okay.